Now here the question is, if a and x0 are positive real numbers and xk be defined as follows: xk equals 1 by 2 xk minus 1 plus a upon xk minus 1, then prove that xk is monotone decreasing and bounded, and then calculate the limit. Now x0, it is given that x0 is greater than 0, then x1 will also be greater than 0. So any term in the sequence, say xk, it will be greater than 0. Now if we write this xk as xk minus 1 plus a upon xk minus 1 by 2, then we know that arithmetic mean is always greater than or equal to its geometric mean, and its geometric mean will be under root of xk minus 1 a upon xk minus 1. So this xk minus 1 will cancel. So from here we can say this xk, it will be greater than or equal to under root a. That means the sequence is bounded below. Now we'll find xk minus xk minus 1 will be xk minus 1 plus a upon xk minus 1 divided by 2 minus xk minus 1. So we can write this as a minus xk minus 1 whole square upon 2x k minus 1. Now xk minus 1 will be greater than or equal to under root a. So this a minus xk minus 1 square, it should be less than or equal to 0. So from here we can say this xk, it should be less than x k minus 1. That is, this sequence is monotone decreasing sequence. Now the sequence is bounded below and it is a decreasing sequence. That means the sequence, it converges. So if it converges, now let us say it converges to limit L. So if we take this limit k tends to infinite, then we can write L equals 1 by 2 L plus a by L. That is, L square equals a, or the value of L is plus or minus under root a. Now the sequence, it contains positive terms. So the limit point of the sequence will be under root a. So this limit k tends to infinite, ak will be simply under root a. Now here the question is, show that the sequence an defined by an plus 1 equals 1 by 2 an plus 9 upon an, where n is greater than or equal to 1 and a1 is greater than 0, it converges to 3. Now we are given that an plus 1 equals 1 by 2 an plus 9 upon an. Now any term of the sequence, it is a positive number. Now if we write an plus 1 as an plus 9 upon an by 2, then arithmetic mean, it is always greater than or equal to its geometric mean, which is 3. So this an plus 1 will be greater than or equal to 3. Now if we write an plus 1 minus an will be simply 9 upon an minus an by 2 will be 9 minus an square upon 2an. Now since an is greater than or equal to 3, 9 minus an square is always less than or equal to 0. That means an plus 1 will be less than or equal to an. That is, this sequence is monotone decreasing sequence. Now since the sequence is bounded below and it is monotone decreasing, it is a convergent sequence. Now we need to find limit of the sequence, and let the limit point be L. We can write L equals 1 by 2 L plus 9 by L. So from here we'll get the value of L as simply 3. Simply 3 because we have to take positive value of this limit point. So this limit, it converges to 3, and that is the answer to this question.